Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hi, welcome to Pytorch tutorial. This is the 8th video of the Pytorch tutorial series. Today's topic is gradient descent, stochastic gradient descent, and batch gradient descent. We will discuss which one works faster, which one is slower, which one is better in accuracy on a certain number of epochs. Initially, when the concept of neural network was introduced, the only type we used to run our model on was gradient descent. But as the size of the datasets grew, we wanted our model to work faster on bigger datasets. And to do that, the concepts of batch gradient descent and stochastic gradient descent were introduced. Today we briefly discuss them in this video. Of course, they come from some mathematical standpoint, but that is beyond our scope of discussion this video. One thing to notice here is that in Pytorch there is only one optimizer called optim.sgd to vary all these three categories. I have used optim.sgd in one of the previous videos, but I didn't talk about whether it's a batch gradient descent, stochastic gradient descent, or gradient descent. Today I'll tell you about all these three categories so that when you are working on a real project, you can play around with batch size to vary all these three and decide on which one is necessary for your project. Okay, let's begin. First we import torch, torch-vision, torch.nn, torch-vision.transforms, torch-vision.datasets, autograd. To plot our data, we use matplotlib, and we import time to check which one is faster and compare the efficiency. We are using mnest, and I'm keeping my data in my_data folder that will appear here shortly, and here it is. Okay, first category is batch gradient descent. So for that, you keep your batch size as 100, but the logic is you need to keep it in the range of minimum to maximum batch size. So the minimum batch size is 1 and the maximum batch size is size of the dataset, right? That is 60,000 for training and 10,000 for test dataset. But since it's batch gradient descent, we have to keep it in this range. So I can keep it 1000, but for now I'm keeping it as 100. So let's load our data in train loader and test loader. I'm keeping the number of epochs as 10. So the concept is, once the train loader is loaded on batch size 100, each train loader will have 100 images, and each time you run an epoch, the performance will be calculated as the average performance of all the 100 images. And same way, the next 100 images will be taken and the performance will be calculated as the mean performance of those 100 images. And how many times these 100 images will be loaded? The answer is 600. See, there are 60,000 images for training, right? And each train loader has 100 images. So the length of the train loader is 60,000 divided by 100. And similar way, the length of the test loader is 100, and we use a simple MLP on our data, and we train our batch gradient descent. All this time that we have been working on our neural network, you might not have noticed that although you are using stochastic gradient descent as optimizer, you are actually working your model as batch gradient descent, not exactly stochastic gradient descent. It's just the optimizer is stochastic gradient descent. So I've also printed out the time. So each epoch takes approximately around 5 and 5.5 seconds to run, and the accuracy starts from 36.59. You have to keep note of that. This will be crucial in the later part of this video. So our accuracy increases with each epoch, which is a good sign, which means our model is learning. And after 10 epochs, our final accuracy is 83.83, which is not bad. Okay, now let's check out our stochastic gradient descent. To implement actual stochastic gradient descent, you have to keep the batch size as maximum. So for training, the maximum batch size is 60,000. For testing, the batch size is 10,000, which means now my train loader length is 1, test loader length is 1. So I'll quickly run it and I'll tell you about some more concepts of SGD. So theoretically, when you train your model on train loader, there is only one train loader, right? And it has 60,000 images, and the performance is basically the average of all the 60,000 images in each epoch, because in train epoch I load the train loaders, and in SGD there is only one. So theoretically it should give a worse performance than batch gradient descent, but it should take lesser time. Let's check out how is it performing. Okay, time wise it's taking almost same time, but accuracy wise you can see it's performing much worse, much worse than batch gradient descent. The reason for this phenomena is that when you train your batch gradient descent, it's taking the average of only 100 images, but when you are training on stochastic gradient descent, it is taking the average of all the 60,000 images in each epoch, right? Okay, now let's see what is gradient descent. Gradient descent is actually implemented by using the minimum length. So now the batch size is 1. So when I run it, which means my length of the test loader is train loader is 60,000 and test loader is 10,000. Okay, let's run our GD. Meanwhile, I'll tell you about the concepts. Okay, so now each train loader has only one image, and at each epoch the model has to go through only one image in the train loader, and since it has to go through only one image at each epoch, as I have shown here, the performance will be very good because there is no mean, but look at the time. It takes a lot of time, almost 3 minutes, 2.5 minutes to run each epoch, because now it has to go through 60,000 train loaders and 10,000 test loaders in each epoch. But this performance is awesome. It starts with 91.69%. So here lies the trade-off between all these three concepts. So initially, when all this started, the stochastic gradient descent and the batch gradient descent, these concepts were not there, and we were training our model on simple gradient descent. And it was taking a lot of time, but we were getting very high accuracies on a good model. But we wanted to run our model faster. So new concepts of SGD and BGD was introduced. So SGD takes only one input data at one iteration and calculates the backward propagation derivatives and updates based on only one input data. That's why it gives a worse accuracy, but the time is good. Okay, you must be wondering how come it's giving only 15.02% accuracy. The thing is, since it's very slow, I have mentioned many times in the previous video that our goal is to reach the minima of the loss function. So the loss function, to reach the loss function minima, SGD takes a lot of time. So you have to run many epochs, but as your training dataset grows very big, the performance of SGD will be remarkably good than GD and BGD. Having said that, we usually prefer BGD over GD if the dataset is not that big, because in this case 83.83% accuracy is, I think, good enough given the amount of time it took. But if the dataset is very big, we usually prefer SGD, because although it takes more epochs to reach the minima, it will take very less time compared to BGD and simple GD. Let's wait for our GD to run. Okay, now that our training for gradient descent is complete, we can say that the testing accuracy after 10 epochs is 96.82, which is much higher than the accuracy after 10 epochs compared to both SGD and BGD. So let's plot our data and see how the statistics look like. So the test accuracies are, of course, the highest for gradient descent, medium for batch gradient descent, and lowest for stochastic gradient descent. If we plot the runtime, you can see that stochastic gradient descent and batch gradient descent has almost similar time frame. They are actually overlapping. So we can see that the stochastic gradient descent is very slightly higher than green, I think, and the runtime for gradient descent is, of course, the highest, almost 157 seconds per epoch, and the training losses decrease for all of them. Of course, for batch gradient descent there is a sharp decrease. For gradient descent there is a decrease here, and for stochastic gradient descent it's decreasing but very slowly. Like I said, stochastic gradient descent, for each epoch the minimization of loss is pretty slow, but if the data set is very big, it will run faster than the other two. Thanks for watching.